37 ना? Okay.
आपका 42 ना? सही।
Manjula madam, please mute.
Now, I am requesting the Group 3 leader Sri Ramnayan sir to present third day proceedings, brief overview of what happened on third day. Group 3 Ramnayan sir.
Sir. Good morning to all. I request Priya Madam to present the report.
Good morning, everybody. Today I am here to present the report on Paradise activity of the student workshop. The day started with a prayer ceremony and followed by a report on the previous day's happening. Our workshop director, Mr. Sri Kumar, principal, NDPC Ram presented the day's program to be taken up by the resource person, Mr. V. Satyanarayana, TGT Maths Theory Journal, and Mr. M.S. Kumar Swami, TGT Maths Theory Flexibility. Mr. M. Brahmana, TGT Maths Theory, NDPC, has coordinated the course. The resource person, Mr. V. Satyanarayana, clearly clarified the difference between the mathematical models and mathematical models, has taken interesting examples and presentations by using the and explain the steps involved in mathematical models, that are understanding the problem, mathematical description and formulation, solving the mathematical problem, interpreting the solution and validation of it. Resource person Mr. M.S. Kumar from taking different examples and guide us how the mathematical modeling is done to solve a problem and to asking presentation. Both the research persons clarified the doubts raised by the participants. We have worked for our group work as well and the day's activity for the presentation of mathematical modeling by participants from all the groups at 6 p.m. Really students who are wonderful students and family for our opportunity. Thank you everyone for giving me this opportunity to present the great report.
Thank you, madam. Thank you very much. Now, I am requesting our Honorable Research Person Manivannan sir and Prajisha madam to start today's proceedings.
Thank you, sir.
Thank you, sir.
Delegate Director of the course, Sri Shravan Kumar sir, Principal NTPC Ramagundam, and thoughtful teachers of Hyderabad region. Very good morning to all of you. I had been associated with many of our teachers since 1987. The faces are familiar to me. And I am very happy to share as I feel at home. Thank you teachers. Thank you principal sir. The fourth day of the workshop starts with the more psychopedagogically related topic, problem-based learning. So mathematics, so immediately the word which strikes our mind is a problem. So we are the capable persons as we handle mathematics, the problems throughout our platforms. An understanding of learners, educational aims, the nature of knowledge, and the nature of school as a social organization can help us arrive at principles to guide classroom practices. Conceptual development is thus a continuous concept of deepening and enriching connections and acquiring new layers of meaning. Simultaneously, our children must be able to come with explanations for why things are the way they are and the relationship between the cause and the effect. They are able to improve upon concepts and reasoning. For example, we can start like this. What is a problem-based learning? Let me introduce a question as we regularly practice in our classes. Find the LCM and the HCF of, for example, two numbers I am giving. Find the LCM and the HCF of 210 and 14. So this is the normal way we are interacting with the children for interrogative sessions. Now, after learning few things under the topic problem-based learning, though the topic we insist upon, all these years we are practicing without the banner problem-based learning. Without these phrases, no maths class would be fulfilled. Now, the same question can be reformed in this way. That is, the LCM and the HCF of two numbers are 210 and 14 respectively. The first question, how did I say? Find the LCM and the HCF of 210 and 14. The same question can be improvised like this. The LCM and the HCF of two numbers are 210, 14 respectively. How many such pairs are there? So this is the question. So let us come with the answers in the afternoon session for this particular question now. Let me not reveal the answer at present. Again, we should a little deeper understanding over the phrase problem solved learning. A more general, the definition of problem. Without this word problem, we never come across a day in our life. So the more general definition of problem is a situation with a goal, and it means the goal is not in known advance. There is a problem, it's a situation, the goal is not known in advance. As the great mathematician George Polias said, a problem is when you are hungry late at night and you rush to the refrigerator is empty. Then we expect that the solution would be in the refrigerator. It was not found, so then we find the alternate solution and the right solution.
Which is good.
Correct solution.
Identified.
Right.
But,
yes. After learning, what is problem-based learning? How to implement in our classes? There are only 3 suitable phrases. From what content to cover what real-world problems at present? From the role of lecturers to the facilitators. From the role of students as passive learners to that of active problem solvers and self-directed learners. To start with, there are few preliminary steps under problem-based learning. That is, steps to follow problem-based learning. First, let us explore the issue. A problem is given to us. Now, what is the answer? What is questioned now? That is, let us explore the issue first. Second one, state what is known. Suppose a question is there. This is not only for mathematics, for every problem. So I generalize here introduction. So particularly when we start up our problems, then we concentrate on that. Because let us all be little thorough with and understandable problem-based learning. So state what is known. A problem is put before us. So related to that, we should have some fundamental knowledge and define the issues that a particular problem, what we are going to find with the answer now. What answer is asked, how we are going to solve that one. Then research the knowledge for that particular problem, what and all the result-oriented applications and knowledge we are linked with, we have already known. Next, investigate solutions. Is there only one way to find out solution for that particular problem, or multi-solutions are there? Then present and support to the chosen solution. Now, we are going to say, sir, this is the way of finding solution for that problem. That is the next point. Then finally, review our performance. So after formulating all these things and revealing, and after exposing, explaining and demonstrating to children, finally we will review our performance. Right. Now, let us start with the examples one by one. Let us start with a sum under problem-based learning. Learner teachers, here is a sum in 721Y3. As I read by digits, as the digit Y, as the digit in tens place is missing. Otherwise, all the numbers, we can advise our children also. Whenever they see the number or read the number, let them all practice to read the number with the proper place value, not like mentioning the mobile number. Now, here is a number, 5-digit number, 721Y3. Now, what is the possible value of Y so that the number is divisible by 9? Now, this is the simplest question for class 6th standard children, and under divisibility rules, these types of sums are coming. Now, any one of us gave the instant answer for this. Kindly, teachers, what is 5, sir?
14.
Is 5, sir. 5, sir.
14.
Now,
Etc.
5.
yes, suppose under problem-based learning, if we deal the sum of same type, let us modify the sum like this. So here is a number. If 2, 3, A, 6, B, that is ones place and the hundreds place numbers are missing. So is a multiple of 9 and 4. That number is multiple of 9, also multiple of 4. So what are the possible values of A and B? In previous case, by adding the sum of the digits, if it is divisible by 9, and what digits should be substituted in the missing place. So we substituted a suitable number, only one number, then we gave the instant right answer. Whereas the same question has been modified a little. Now here 2 digits are missing, and also this number is a multiple of 9 and 4. My first suggestion regarding this to all of you. This number must be a multiple of both 9 and 4. So we should devise what will be the digit. Suppose if we substitute one number for A and B, it may be a multiple of 9, but it may not be a multiple of 4. Again, another 2 digits, another 2 numbers, we are substituting for A and B. Now, this number may be divisible by 4, may not be divisible by 9. For us, the condition given is, we must substitute the alphabets with the suitable numbers so that the number must be a multiple of 9 and 4. Or, on the other hand, it must be divisible by 9 and 4. It is understood now. Right. Can any of our learned colleagues give the answer?
3480 or 08.
A is 3.
3, 4.
3480 or 08.
A is 3, B 4.
7, 0.
My sincere teachers, if they give the answer one by one, it will be audible to all of us. Then it will be a fruitful session, please. Because I am also teachers, please. I am also the lowermost learner among you. Most of our participants, we are being attended the courses as I told at the beginning. After seeing the face, I blushed and smiled at them. Since 1987, we are attending the courses. I am also a learner among you. Kindly share the things one by one so that every one of us can learn beautifully. Please, sir. Please, madam.
For 340880.
Sir, 80.
70.
70,
sir.
sir. A
770
7,
7007.
B, 0.
3, 4, yes, sir, 3, 4.
0, 07 नहीं होगा, 07 नहीं होगा.
07, no.
6 and 0, sir.
Sir, any other possible substitutions?
3, 4.
A is equal, sir, A is equal to 3,
A
7.
is 3, B is 4.
B is equal to 2, 6.
Well said.
A is 3, B is 4.
3.
Then
A is B can be
now we
4.
have come out with the 2 solutions. Any other?
7, 0, sir.
8, 8. 8 and 8.
Yes, sir. 8 and 8.
8 and 8.
8,
8 and 8.
yes, sir.
8 is 14, 14 is 3.
Yes. Now, so like this, when we give sums under problem-based learning, now let us give as many possible solutions. On the other hand, this multiple answers for a particular solution enhance the children's thinking attitude. Now, if there is only one concrete answer, if one child finds the answer, then there may be a hindrance. There may not be a chance for further elevative thinking. That is why these type of sums under problem-based learning is insisted for us to implement in our evaluation platform. This is our second question. Respected teachers, the questions which we are going to deal today may not be very complicated or may not be higher order thinking. Our concept is we concentrate on problem-based learning. A problem is put before the children, so they must think and come with the multi-dimensional answers. With that answers, it may not be coordinated to only this particular topic, and it may be extended to other topics of mathematics and other areas of other subjects also. That is the ultimate aim and objective of problem-based learning. So here is another question. So compare with the magic squares, this is nothing. Compare with the magic squares, this is not that much difficult. But when we find a solution for this, even finding solution for this particular sum is simple. Then under the topic problem-based learning, how we are going to implement these things in our classrooms. That is why, that is the main idea of us. Now, this is the second question. Using each of 1, 2, 3, 4, 5 and 6 ones, that is only ones, fill in the circles so that the sums of the numbers on each side of the three sides of the triangle are equal. Now, my question is there only one such answer is there or multiple answers are there? Suppose if we give one answer, what is the fundamental principle or what is the relation between the order of the numbers? Yes. Shall we start with the first answer?
6, 2, 1, 4, 3, 5.
Yes, that is on the, now let me ask like this, left hand side. That is left hand side, top to bottom.
Left hand side we can fill 5 to 6.
Yes.
6 to 4 also.
Horizontal, left to right.
Horizontal, sir.
Horizontal, left to right.
4 to 6. 4 to 6. 4 to 6.
6154.
Again from bottom to top, right hand side. So that everybody can understand.
So 435.
Sir, one of you, madam or sir, one of you, kindly repeat the answers you told. Kindly read the numbers. That is as I told in the order. Left hand side from top to bottom.
So
Again,
4 to
horizontal level, again left to bottom. Again right hand side from bottom to top. You can tell the numbers in order, madam or sir.
6, 2, 4, 4, 3, 5, 5, 1, 6.
Yes. Respected teachers, are you all satisfied with the answer presented by our teacher?
Yes, sir.
Yes, sir. Correct, sir. Right. Is there any other alternate answer?
Yes.
Madam, please. Only one can present. Now we have got one solution now. There are multiple answers for this sum.
Sir, better first of all we fix 6, 4 and 5 on the vertices of this triangle, sir. And then we can rotate these three numbers, and according to those we can fill 1, 2, 3.
That means, sir, you are changing the order.
Yes, sir. That is only one. That is only one possibility, sir.
No, no. Let the numbers in whatever order you write, whether it is from left hand side or right hand side or bottom, that is 3, 2, 5, 1, 6. In that 6 circles, once you present the numbers, even if you change, that is the same pattern we can consider. Different numbers, the possibility of different, some other numbers I am asking. Even if we change the order, we will consider that is one set of numbers.
Second row and third row ends interchanging.
No, sir. Let us not interchange. You come with the solution with the different numbers.
Rotate the triangle. 3 triangles will be there.
Sir, 614.
Yes, fine, beautiful.
632.
452. Yes.
Yes.
Now check with the answers. Teachers, check with that. Is it correct now?
Yes, that's correct.
This is what we expect. That is the ultimate principle of this type of sums.
So 351.
Madam, yes, please.
351. 342.
Yes.
16.
Now check the sum.
9, sir.
Fine.
All the way right.
So, like this, as many we can give for our children in our classes. Now, let us look upon this sum. Draw the next 3 figures in this pattern. That is, first one, a triangle. It is a 3-sided polygon. Next, this may be a square or a rectangle or whatever it may be of a quadrilateral type. 4 sides in which 2 triangles are there. The next, another figure, thereby 3 triangles are there, and it is constituted with 5 sides. Right. But now my question is, how many triangles are there in a figure with 10 sides?
8 triangles.
Now, here is a principle, respected teachers. Here is a principle. Whenever we deal these type of sums before the children, so many will come out with the answer, guessing answer. Now, we will let them come with the answer. We will welcome first. Then immediately, so they can be guided under some principle. They have to find the next one like that. For example, from 3 sides to 4 sides, with always with 2, we cannot generalize a rule. Now we compare 1 and 2, and 2 and 3, and the first 3 sides. Second figure shows 4 sides. Third figure shows 5 sides. Now, under what common principle now this question is being set up? Any common formula or any
n minus 2, sir.
Sir?
N minus 2, n equal to number of sides.
Yes. Beautiful.
N minus 2.
Yes. Can you say how many triangles are that figure with the 10 sides?
8 triangles.
8 triangles.
Minus 2.
8 triangles, sir.
So now, let me put a question before you. Can any one of you draw a figure of this type in a paper? Let us all visualize through the video. Please, teachers, any one of us, or many of us, because all the demo may not be possible to visualize. At least 2-3 teachers can show. So instead of triangle, some other type. are of the same type, that is a 15th one or 12th one, 11th one, like that. Few seconds, a few minutes, because we have a lot to observe today.
So, Manivandan sir, one small doubt I got in.
Sir, yes, sir.
Sir, if you will explain this question like this, it may give wrong impression to the students so that they will apply that everywhere because you are not using all diagonals here, right?
Sir, not clear, sir. Please, voice is not audible.
Sir, actually, here we are not drawing all diagonals. Hello?
All diagonals.
Yes, we are not considering all diagonals. Otherwise, we will get number of triangles, means we will get some different answer.
Yes, sir. Now, in this, our idea is how many triangles are there? How many triangles are there? For example, if you consider this diagonal, it is common for these two triangles. Let it be. That doesn't matter. This diagonal is not only for this triangle. Similarly, here also, here there are this side is common for this triangle 1 and triangle 2. Again, this side is common for triangle 2 and triangle 3. Whereas this is a plane figure, it may not be. It is not actually. Our idea is we are getting triangles from this figure. It may be three-dimensional solid also. Need not be plane figure.
Sir, your question is 100% right. What I am saying is, the student may get a wrong impression that this formula can be used anywhere, like that. So, it's better to mention there that the diagonals are not intersecting diagonals, if I am not wrong. If we mention that one, then it will be okay.
Yes, sir. Diagonals must not intersect each other.
Sir, but we are not mentioning about diagonals, sir. We are not talking about diagonals. We are just simply to observe the figure, sir.
No, madam. What I am saying is, see, 100% right. This,
I understood, sir. I understood, sir. Yes, sir.
Principle. Sir, here the question is, we look at the figure. And the first one triangle we have drawn. Second one, a figure has been drawn and two triangles are present in it. With the sum principle, from the first diagram, I have extended the second diagram. Again, with the same principle, I have extended the third diagram. No other principle I have taken in this. I am counting as many triangles are coming from the figures one by one. But when I get as many triangles from 1 to 2, 2 to 2, 2 to 3, 3 to 4 like that, there is a common principle. With that principle only, now we are looking into. There may be 101 principles based on this when I look at this figure. Now our idea is how many triangles are there when we extend like this. That is what I told. As Sir told, a child may come with another principle and idea also. Now our question is, because if we fix as many principles for a particular sum, it may obey with some properties, it may not obey with some other properties. Sir, for this particular property, it doesn't obey. That is not our idea. Our basic idea is the extension of these type of figures at this juncture, how many sides or how many triangles will be there. That is only. Am I correct, sir?
Sir, I accept. Yes, sir. Yes, sir. Thank you, sir.
Yes. Now, your principle is excellent, sir. Now, here with that principle only, we are proceeding through for this particular sum. Yes. Now, study the sample diagram. Note that. Listen. You just look at it. Yes. Here are two sums. Each sum may have different solutions. The first one, let us concentrate on. Let us concentrate on the first one.
Previous one, sir.
Sir, kindly,
Previous one.
one of us, please come with the answer.
Sir, kindly show the previous slide, sir.
Yes, please.
Sir, first one is 87313, if I am not wrong.
Sir, we'll see. Sir, shall I move? Once sir told to watch this one. Shall I move, sir?
Yes,
Sir,
sir.
yes, sir, yes, sir.
Okay, sir. Sir, first one, kindly tell me the answer, sir.
87313.
Okay, that is first row.
Horizontally, I'm telling.
Horizontally, you are telling. Sir, please.
87313.
7330. Okay, teachers, what sir tells correct?
Yes, sir.
5 horizontally 5 and 10, and bottom line 6 and 10.
Yes, ma'am.
That
Yes,
is
ma'am.
also correct.
Right, ma'am.
5 and 10. And then below that, what madam told that? 6 and
10.
10. I need not be repeated. No?
Repeated. Okay.
Yes. No repetition of numbers.
So can we repeat number? No.
Sir, what number you want me to repeat?
69511. 69511, sir.
Sir, 21397.
69 and then
69511.
511. Yes, beautiful.
Sir,
Beautiful.
21397.
2, 3.
9511.
Sir, 9 here, you are telling. 2, 3.
213, 9 and 7, sir. Vertically,
7,
we
8.
see vertical.
12.
2, 3, 9, 7.
7, 8, 4, 12.
Beautiful. So, let me for this second one, please. So, as many examples,
9 to
Second one.
8,
4,
4,
8, 6,
217.
13. 4, 8, 6,
as
13.
many choices are there. Second one or two will
8,
discuss.
4,
Second one.
217.
4.
Beautiful.
7, 5, 3, 16.
5, 7, 5.
So, few solutions have been given. So, there are multiple solutions. Material will be provided to you. Need not copy or take photo.
84217.
Sir, 93118.
Madam. Fine. Yes. Let us move on to this one. How many rectangles are there in each of these figures? So, first one rectangle. Second one, 3 rectangles. And third one, how many
1,
rectangles
2,
are
3,
possible?
4, 5.
6, sir.
6, sir. Third one,
Next
6.
is
6.
6,
1,
sir.
2, 3, 4.
next one,
1,
1
2, 3,
rectangles.
6. And then what will be the next
1,
number if we extend these type of figures?
9.
Some of the first and natural numbers.
8, 9, 10, 11.
Sir, is there any coordination between
1,
this series of
4,
numbers?
6, 8.
Yes, sir. Some of, yeah, there is nothing but some of first and natural numbers. If you like.
Sum of natural numbers. Still, it
First
could
and
be
natural.
generalized, sir.
Sorry, sir.
Still, it could be generalized. A generalized rule can be proposed for this. 1, 3, 6, 10, and go on.
Factorial.
On the other name, one more name also, factorial correct. N factorial, then other name also, sir. Will it be triangular numbers? Right. Because, sir, when we approach these type of sums, Sir, the sums are easy, sums are difficult, sums are average. The examples. It is not the level of we teachers after this many years of experience. Now, those who have been promoted from primary to high school, we had been the experience of Yashpal's recommendation in our primary classes, that is competency-based learning. Language means the evaluation of children with 5 different skills, competencies. Mathematics means 4 different evaluation with 4 different competencies. Environmental studies means 3 different competencies. It would have been extended to class 6th, 7th, 8th before a decade at least, or before 6-7 years at least. So till 5th standard, it was stagnated. It was not further extended, and it has not been recommended by our authorities. Now, this is the time they would have realized those competencies. It would have been extended first level, 6th to 8th, and then to 9th and 10th. Now, when we look upon some problems here, more than the stuff of the question, more than the higher order capacity of the question, one question we are taking and we are giving multi-dimensional approach to that particular question mathematically, taking understanding the basic concepts, ability in computation, and forming numbers correctly. That problem solving ability now we can modify as a problem-based learning. So this is the main idea and the principle of this course. This is what my little understanding of this recommendation says. Shall I move on to next sum? Yes. A simplest sum, addition to answers for this. Now I will ask our friends, now under this principle, based on this principle of this sum, and can we propose a sum of this type, or what is the principle behind it when we impose these type of sums in our classes? Now, how many crayons are there in each box? Each box has the same number of crayons, and first 2 obviously seen. The next 3 boxes have equal number of crayons in that. The last 12 number of crayons are there. So within no minute, our friends can give the answer. Kindly give the answer. Then let me start to the second question on this.
10.
10. Yes, beautiful. Now the next question, my humble request to one of you, right? Why should we teach these type of sums in the classes? We can give as many modifications of this type. And what is the principle behind it? Why should we give this type of sums? If we understand that one in our evaluation process, we can give as many sums of this type, which will satisfy the problem-based learning. Kindly teachers, one of us please. An example I tell you.
Sir, this is an
example I tell you.
Hello.
And how many of you,
Hello, sir.
Agree with me? I do not.
Yes, sir.
Sir, now the teachers of us, many of us at the age of 57, 58, and many teachers are around 45, and maybe the 25, 24. When they came to high school, the curriculum was revised. Those days, we were very much insisted in by the mathematics teachers to memorize multiplication table. Now we all are against rote memory, but I can very well say that rote memory is entirely different from memorizing the multiplication table. Sir, kindly one of you recommend my point at this point. Though many do not agree with me, is there wrong in memorizing the table at the beginning stage? I am asking now. Now, if we answer to that question, very well we can give what is the principle behind this question. Like what is the use of learning the fact? For example, 7 8s are 56 without multiple addition and that is subtraction from the previous step and opposite of division, opposite process of division. Instead of learning all these things, simply I memorize 7 8s are 56. What is the advantage?
Sir, I do agree with your point. Rote memory should be there in tables because for quick calculation or fast calculation or for time saving, and it is memorized throughout the life also. What we learned, as you said, what we learned in our early stage will be memorized throughout the life, which is useful in all steps.
Yes.
That is what I say.
Sir, excellent, sir. Addition to your point, may I say a few points, sir? Sir, when we learn 8 7s are 56, the multiplication facts from the multiplication table, though we memorize first, within short time, we learn all the 4 fundamental operations of mathematics, fundamental arithmetic, by learning multiplication table. Till 10th standard, we can challenge anyone if a child is thorough with fundamental operations. They do not even know about the topics trigonometry or statistics or probability or any other algebraic topics. Now, simply by practicing and thorough with the fundamental operations, we can challenge all will get to 33%. That those who are struggling for pass mark. So this was the practice in earlier years or now also for many of us. Even in 10th standard, fundamental addition, subtraction, multiplication, division, we are giving practice for all the children in 3 different categories, L1, L2, L3, that is with rational numbers for 10th standard children. So even the bright child, he is losing centum, or many are losing 3-4 marks, the bright children. The reason is they know addition, subtraction, multiplication, division, but they are not precise with the calculation. It will come only by practice. Am I correct, sir?
Sir, here I will tell my experience.
Sir, please.
My personal experience. Actually, I was an MSc student. When I was in BSc, we had a friend who is having a commerce background, BCom. Means generally commerce or arts means comparing with science students, generally they are weak. Generally there is that the attitude is there among everybody. So we all prepared for a bank test, and he also said, I will also apply with all of you. I will also prepare with all of you. Then we said okay, but just like Dr. sent that story, that he was selected. We all BSc students, all science students, we did not select. But who is not having a maths background and who is only a BCom student, average student, he only became successful in the bank test. Now he's a manager in a state bank. So here what I want to say is, as you said now, we know all mathematics, as you said, we know statistics, trigonometry, calculus, calculus. We did so many times we did. So we thought that it is very easy. By what is bank test, we can easily win over. But we could not succeed. But that person who practiced well, actually those days bank test means very simple test. Nowadays, there are 2 stages, but in those days there were only one stage. Only one stage.
Yes.
That too only simple calculations.
Yes.
Not even word problems also.
Nice.
But he practiced, and what he learned in his early stage, So with that, with practice only, he could succeed, I say.
Yes, fine.
So here, these are, as you said, basic operations and basic, what we say, practice only work out in this mathematical calculation.
Thank you very much, sir. Thank you, sir. Now, these numbers belong together in a group 25, 40, 110, 55. That is the first instruction of this question. Adding to that, these numbers do not belong in the group. That is, under one principle, 4 numbers have been given in the first line. And again, I am giving 4 numbers, 33, 71, 4, 106. These numbers do not belong to that group. Again, third point, which of these numbers belong in the group? That is the numbers of the first group, 75, 205, 87, 43. Now, here are 2 questions. One is, what is the rule that everybody can say? So, what is the rule? Then answer every one of us can say. Within no minute we can say. My second question is, so addition to that rule, any other principle in this? That is my second question. Third one, will there be any other principle related to this concept, number concept? Okay, sir. First, let us start with the answer. Can anyone say what is the rule based on?
Multiple of 5, sir. First one.
Multiples of 5.
That is the answer. Right. That's what I told. Every one of us will be able to give answer. Multiples of 5, simplest. Second one. Now the second part you can reserve for afternoon session also. One of you please come forward with it. Because sharing unknown, very difficult, extraordinary things more than that. And exploring on the known things, simple things will be materialistic in our classes. Because we don't deal with the research students. And all of you do agree with me, I am sure, as on date, all of us are struggling for giving first 100% result. Then only how many 100 scorer are there in the classes. Am I correct, sir? So let us be concentrating all the 3 levels of the children, and even the simplest sum, if we take as an example, if we explore on it, and it will be very much acceptable, and the children will be easily learning these concepts, sir. Yes. Now, here is a figure. 3 questions have been given. 3 questions have been constituted through 3 different competencies as we discussed a few minutes earlier. Now you can share with us how many triangles can you find in the figures below with the answer. So what competency?
12, sir.
How many, sir, we will discuss, please. How many different edges are used in these triangles, and what is the competency adapted to this question? And the third one, if the area of each of the 4 smallest triangle is the same, and this area is 1 square unit, what is the area of each triangle in the figure? And what is the total area of those figures also we can find out. First question, sir, please. Answer, everybody can say. How many triangles?
12, sir.
Other teachers are agreeing with that answer?
Yes, sir.
Yes.
8, sir, 8.
8
triangles, sir. I got
12. Please finalize the answer. 8 or 12. Once are told 12.
8, sir. 8.
8.
8.
So majority 8. We'll see. It might be the correct answer. Right. Next. Now, what is the principle? Simply with some guess, many may give answer. Even our children may come out with the answer. So, under what principle, keeping in our mind, we are proposing this question to the children?
Some of the consecutive numbers,
Sir?
Some of the rational and first and natural numbers formula. That's what we discussed already. You told now n into n plus 1 by 2.
So, competency, one phrase we can say this, whether it is forming numbers correctly or ability in computation, because that will help us to keep the competencies in mind very easily and for further follow-up also, sir. Because those phrases are not very simple. Since 1968, by as many recommendations for our education faculty, but it was not imposed or it has not been read by many of us. So each one has very good principles. When it is brought into practice, only few percentage is coming to platform. In that, a few percentage is reaching the children. So thereby some technicality is also required to remember all these things.
But you consider one diagonal, sir.
Sir, please.
First, consider one diagonal.
Still, sir, no. Like this I am asking whether it is coming under forming numbers correctly or ability in computation or understanding the basic concept. Among the three, one I am asking. Yes. Because these three questions have been framed based on those principles.
Understanding basic concepts.
Basic concepts.
Understanding basic concepts.
Good. Next, sir, so. How many different edges are used in these triangles?
10.
Is it correct?
10.
Different they are saying, no. So 5 it will come. 5, sir.
Any answer?
10, sir.
Then competency?
8, if I'm not wrong.
Second, who said 8?
Myself. Narendra, sir.
Yeah, we'll see, sir. Right. Now, competency. Answer is not a way. We'll see now. Competency. Second one, how many different edges are used in this triangle?
12, sir. 12.
8, 10, and 12. 3 answers have been reserved now. We will see which is confirmed.
Answer.
Next slide, we are going to see the answer. I am also keeping in my hand. So I keep patience for some other reason. Second one, what is the competency? How many different edges are used in these triangles? Second question. Under what? First one, FNC you told me. Second one?
8.
No, he's asking competency.
Competency. It can be understanding basic concepts as they're identifying the edges, they're counting the edges.
Identify and understanding.
Concept of edge.
And explanation could be still concise. Okay, madam. If the area of each of the 4 smallest triangles is the same and this area is 1 square unit, what is the area of each triangle? So then this as many triangle we are getting, each triangle is of 1 square unit. How many such triangles? Finally, what is the total area?
Sir, question is little typical, sir. What is total area?
If there are 8 triangles, 4 are of 1 square unit. And
one kind
4 are
and
of 2 square
one
unit.
another kind.
Sir, if there are 4 triangles, their area is 1 by 4 each.
4 triangles and 4 square units.
No,
madam. Each square is 1. Because area of each of the 4 small triangles.
Sir, let me explain the questions.
Yeah.
So when you find out as many triangles in this, you will be able to compare with one triangle with the other in that area. Suppose if you get the area of one triangle, definitely you will be able to say the area of the other triangle. So for example, these two triangles, for these two triangles, I am telling this is area. This area is 1 square unit. Can't we say this is also 1 square unit?
Yes, yes.
Yes, like that I am asking now. Suppose this is 1 square unit. This is 1 square unit. Can't we say area of this triangle 2 square units?
Yes,
Yes, sir.
Yes, sir.
That's not given in question C. Okay, we'll move to the answer because as many material we have.
That's what they said. 4
Kindly look at this. So second one, 12 is
Sir, we can write like this, sir. We can write.
3 different answers our learner teachers gave. 12 is the correct answer. And C, so the total area we can find out.
14 is this one.
So for all the, if we find out, that is the total area of the triangle. Yes. No. One minute, just take breathe, breathe, because there is a question. So with some critical thinking. So more than the calculation, the language of the sum is very important. In most of the time, our children, not only 6th, 7th, 8th, and even after completion of +2 and graduation and all, when they appear for now, entrance test and all, they know the principle, they know the sum, they know the topic, under the topic, the types of sums they know, but while reading the sum, as they are not thorough with the mathematical language which have been given in these type of sums, they don't succeed to give correct answer. So now, shall we read now? Joan went fishing. On the first cast, she hooked a fish 80 feet from the boat. Each time, she reeled it 10 feet of line, take out the 5 feet. Now, after reading the question, I will explain also. How many times you have to reel it? Teachers, please. Joan went fishing. On the first cast, she hooked a fish. Now, the distance between the fish and this person is 80 feet. Now, each time she reeled, that is, both are moving towards each other. Now, the concept would be clear to all of us. So, each time she reeled in 10 feet, the fish should take out to 5 feet. Now, first the distance is 80 feet between the two terminals. 80 feet. Now, one is forwarding 10, another is coming towards 5, like that. Now, you all would have understood the concept. Now, how many times did she have to reel in to get the fish into the boat?
Is it 16?
By how many movements?
5, sir.
16.
5 times.
No?
5.
Items.
No, sir.
15, I think so.
15.
Sir, answer, pardon, please.
5 times, sir.
15. Who told us, sir? 15? 15.
For myself also.
Sir, 15 is the correct answer. Can you explain, sir? I say 16.
Sir, first thing is,
I say 16. How do you
sir,
say
first,
16?
sir, first you subtract 10, sir, because that is the last test. The 10 you subtract from 80. For 70, to get 70, that means every time 10 minus 5, no. You have to take
Yes.
the multiples of 5.
Good clarification, sir.
14 times 5 into 14, 70. Last
Yes.
time you take, if that one, so it will take risk, then no, it will come back again.
Yes,
It will
that is
not,
the nice.
it will not come back again, sir.
Right. Can everybody understood this one? What Sir explained there? Now, here is another question. A farmer milks 16 cows every hour. The size of his herd varies as new cows are born and he sells off some of his stock. He never has less than 48 cows nor more than 64. That is, at any instant, if we check, the number of cows are not less than 48 and not more than 64. And how many hours does it take him to milk his cows? This is the question now. How many hours does it take him to milk his cows? Another beautiful sum for the example for the topic which we discussed today. Learned teachers, please.
Not less than 3 or more than 4 hours.
4 hours.
Sir, voice is not audible sometimes.
More than 3 or less than 4?
3 or 4 hours.
Beautiful.
3.
Can you explain, madam? Answer is correct.
By 16 करने से आ जाएगा ना sir.
Minimum number of cows he can
48
have
by
is
16.
48 and maximum is 64. So we take as multiples of 16 or we divide by 16, getting 3 and 4.
I don't know whether a good explanation, but whether it is audible to all our teachers, I do not know. But when you go through just once very well, you can understand. And even these type of sums could be discussed in class 7th and 8th. Now, today all the groups will be presenting, sir. How many groups are there? 7 groups, sir.
6, sir.
6 groups only.
Right, 6 groups are presenting daily. So in each group, 2 participants will come forward and present the items. And 1 participant can take a maximum of 4 minutes. So you can come with an example, 1 or 2. Kindly don't extend more than that. This is not a platform to show our capacity building. And if the examples are known related to the topic which we are discussing, that is more than sufficient. So let us complete the session sharply by 5:30. Let us not extend more than that. So in afternoon session, so around 5:30, that too mathematics topic, exploring over this is a difficult task. Every one of us know. So the time limit and the completion of the program is in your hand. I am ready to wait and I am ready to observe even till last late night. So this is an instruction. So each group can come with 2 participants. Each participant can come with a maximum of 2 examples. That even you can come with only 1 example also. Kindly you take 4 minutes each participant, so that all the participants can complete our schedule within the time. Right. Now here is a question before us.
Sir, Manivandan sir, one request. Now most of the teachers, we will go to that meeting, sir. We have to attend that meeting.
Sir, please.
Now most of the teachers have to attend CCT meeting, sir.
Okay.
So we will be back only at 2 o'clock. So we may not get time to do this. Yeah, we may not get time to do this homework.
Sir, in the afternoon session.
Yes, sir. Now we have to go at 11:30 only.
Yes, please.
11:30 we have to attend, sir.
Sir, no. Program I am aware of, very well aware of. If only 2 are present in that group, that is sufficient, sir. So now our Sangadhan is conducting programs simultaneously. What is there? Everything we have to attend. So if some are attending, they need not be in the group. But the 2 will be present, definitely in each group. 2 will be there, no, sir?
Okay.
We'll check, sir. We'll check because most of my.
Among 6 and 7, 2 will be there, no? That is also doubt.
Yeah, no, sir. Definitely 2 will be there, sir. No doubt.
Except those who are attending, you please organize. Even it need not be under the banner of group for today, as there is another coordinating program, and for 1 hour session, around 10 participants we want, sir. So those who, I hope all are not having that program. If 10 participants along with some of our teachers are attending, well and good. And except those who don't have that program must attend our program, that is mandatory. Am I correct, sir?
Okay, sir. Sure, sir. No, only thing is, no, just for your information, sir, all may not do that work. Only 2, 3 can.
You plan accordingly, sir. No problem with that. Now, an Egyptian pyramid has a square base and 4 triangular faces. We all are aware of the figure of a pyramid, and some of us might have visited also. And use clay or play dough to make a pyramid model. If you make different plane cuts through all 4 of the triangles without cutting through the square, which different shapes will be cuts made? That is by quadrilateral or any other trapezium, like that. I would not have revealed that explanation. Just for understanding, I give you now. A plane cut is kind of like a cheese cutter. It will be straight, not curved. Now, can we come with the answer? Which different shapes will be cuts made?
Sir, it means that the cuts are horizontal only?
Yes. Definitely we can fold, madam.
So, all the 4 triangles.
You think of a paper, you just think of a paper. For example, a paper is in the shape of a kite, and then we are folding such a way we are getting a pyramid. Like that I am asking now.
Trapeziums, sir.
4 trapeziums and 4 triangles?
Yes. Sir. Now, answers nice. And my request to 2 of our participants, kindly give you a demo during afternoon session, please. I show you this one. So with this, so a square, trapezium, and kite. Now, if the cut goes through all 4 triangles parallel to the base, a square is produced.
Yeah.
The cut is made through one pair of opposite faces that are parallel to each other and to the base. Then a trapezium is produced. If the cuts are made from one edge towards the opposite edge, which is a different distance from the base, in such a way that other 2 vertices are both equidistant from the base, then a kite is produced. So because of its difficulty, this problem would be better used as a performance event with the students working together than as an walk and response question. Kindly do a few. If a paper folding, if it demo is given in the afternoon session, in our record we can keep it with the participant name and all. And it is an added glittering to the whole 5-day program of this workshop. So any 2 teachers kindly come forward and make a cutting, and that snap can be taken as a video and can be put in Hyderabad region group. Sirs, madam, do you agree with me? Teachers? Any two? Kindly acknowledge, please, my request. Yes. We proceed to next one. Using each of the digits 0 to 7, 0 through 7, and wants to fill in the spaces below so that the difference is 8. The difference is 8 in the hundreds place, 8 in the tens place, and 9 in the ones place. Now, let me read it till the end. Then I give you explanation. Then we can give answer. Is there more than one solution to this problem? Explain briefly. Yes, there are multi answers. Is there more than one solution in which the digit in the thousands place of the difference is 0? That is one choice of the solutions. Now, one question first. We are going to find a solution for this. Second one. So when we teach these type of sums and they practice these types of sums under this today's topic, what competency or what the additional skill and what is the major principle behind it which children could learn. First, let us come with the answer. It will be interesting.
Each of the digits 0 to 7.
Kindly read all the 4 digits together, not one by one. The top number and the second number, all the 3 digits. One of you kindly read, please. Yes, please.
1 minute, sir.
Sir. The first top 4 digit number.
Sir, 3640.
Fantastic. Second one.
751.
751. Do other teachers agree with that answer? Check the difference. I don't check. You kindly check.
Yes, sir.
Yes. Now, let the first digit be 0.
3640.
The answer. That is the answer of
364.
Madam, please.
Sir, in the first row 3640, in the second row 751, and in the last box there is 2.
No, madam. That one or two examples you have seen of that type. Now I am asking, in the answer part, the first digit is 0. The first digit is 0. For that, I am asking an example. That is, answer is only 889.
Sir, 1000 minus 111.
Sir, 1000 minus 111. Correct, sir. Now digit should not be repeated now.
Okay.
No repetition of digits. Use the digit only once in that. If we have the choice of repeating the digits now, a million number of examples we can give.
So for this only guessing work only, are there any sort of steps? No.
Madam, please.
For such type of problems, steps if are there or only simply guessing work, sir?
Louder volume.
Only guessing work or we need to...
That is what I told them. Not guessing and giving. What is the principle? Simple addition, subtraction. Fundamental only now.
Sir, 1593704.
Sir,
1593704.
You check the answer. Teachers, kindly check. Is it correct? What sir said?
One 1593704.
Yes.
Yes, sir, correct.
Yes,
it is correct, sir. It is correct.
Answer is correct. Madam asked, yes. Now, not only this particular sum. In mathematics, we deal even any topic. The addition, subtraction, multiplication, division is the fundamental principle. Here, with that principle only, simply we are adding or subtracting, and with the different digits we are giving answers. Now, what is the basic principle now in this? When we add this number with this, under this one's place or tenth place or hundredth place, that is one principle. And another principle I expected from you. What other principle children can learn and practice in this type of number work?
Subtraction by regrouping.
Madam, please.
Subtraction by regrouping.
The voice is coming with the echo, madam, please. But giving the beautiful answer, I hope.
Subtraction by regrouping, sir.
Subtraction by regrouping. Yes, that is one. Subtraction by regrouping. I am at the point of learning. That is why I expect from you in this. I would have thought a simple arithmetic or addition or subtraction. Okay, we'll keep on thinking. So, 2 examples of this type. And you also came with as many examples. Next, let us go through this sum. Merlin has a board game in which it is possible to land on spaces worth 1, 3, 5 or 7 points each. Write an equation to show how it is possible to score a total of 10 points in exactly 4 moves. Or all the scores between 5 and 35 possible with exactly 5 moves. Or all scores between 5 and 35 possible with exactly 5 moves. If not, which scores are possible? That is, my second question is, all scores between means 6, 7, 8, 9, 10, all between 5 and 35. Is it possible? Right. Let us concentrate on the first question, A. Write an equation to show how it is possible to score a total of 10 points in exactly 4 moves. Anyone? By 4 moves, you should give the total 10.
One one three three.
5 3 1 1.
1 1 1 7.
Sir. 1 1 1
7.
Beautiful. Four movements. And then another example.
1133.
5311.
133, no.
1135.
1135.
1135, correct. Another example.
1333.
1333. 7 so far we have not used it. 7. First
1117. 1117.
Okay. Right.
1117.
Sir, 111.
7.
That's first teacher told the same, na?
Yeah.
3 times and 7. Yes. Okay. So as many examples. Now second question. Kindly answer to second question.
There is a chance of getting 49 also, which is greater than 35.
Round score between 5 and 35%.
Now which scores are not possible? That is the question. That is, are all scores between not possible? No, I can say. But particularly, which scores are not possible?
5.
7 is not possible, sir.
7 is not possible, no, sir.
In
All
general,
7.
you can say. Sir, for that question, in general, you can say. You take any of the 4 moments, are you getting one particular type of numbers? But this clarity would not be there for the children when we say. They should find out actually. We are in the learning platform, in the teaching platform to teach the children. That is why there is no fuss or not knowing things simply like a boomerang giving the answer. Not like that. Even the known answers, how to deal with the children are with the same. I have given you some questions. The same questions can be improvised with still higher order learning so that it will be open-ended for problem-based learning for the children.
Not possible, sir.
For what type of numbers not possible?
All 7s, if you take all 7s, it is 35, no, sir, not between 35.
Odd numbers. Only the odd numbers are not possible. This is one example, but as many examples our teachers gave, this is the one not possible. Right. Now we have come to the end. Now take this question, and this question answer can be explained in the afternoon session. One of us. Welcome to the world of Orient. Spoke the genie to the Aladdin. You see before you diamonds, rubies, and emeralds. 2 diamonds were worth as much as 3 rubies. 5 rupees are worth as much as 9 emeralds. Make a pile of diamonds and then make a pile of emeralds. If you can do this so that the 2 piles are exactly the same one, you may keep them all. How many diamonds should be in the diamond pile and how many emeralds should be in the emerald pile? Explain your answer. So the answer I expect in the afternoon session. And as you know, our teachers, the program is the next by 11:30. The session is ending now, the first session. Second session between 12 to 1:30, it is individual work by participants. You need not have to discuss in group or something. Individually, you can learn how to think of this concept. And between 2:30 to 4 p.m. afternoon session, after lunch, interaction in group. So the group participants can discuss among you. You would have made a group, and this is the 5th day, the 4th day. And based on that group discussion, 2 from each group will be presenting between 4:30 to 5:30. So I will be joining with you, if possible, in between 2:30 to 4, are definitely between 4 to 5:30 p.m. And from your side, to take into point in the continuous part of my learning, can I get any suggestions or overview by the participants of this group? Kindly, respected teachers, kindly few of you come forward and suggest me things to learn further. And
Dear participants, please interact.
Sir?
I am requesting the participant to express their views and interact with Manivannan sir.
Yes, sir. Please, please.
Sir, it is, I'm Sirishavani, sir. Questions you are giving, okay. Some questions, understanding, I should say frankly, I'm taking little time only. So answers, or whoever are doing answers, they give or do some sort of explanation, it will be nice, okay. At least we can understand. Are you able to hear, sir? Questions you are discussing, okay. Answers, instead of telling orally, if they put up on the paper, it will be better, I feel, sir, because I'm not able to understand at least questions, some questions, not all.
Excellent. Now, our all these materials, will be put in the group, and you can go through. These are all examples only. As you said, madam, we can give clear demo with a few number of questions, but our instruction, so maximum of these questions and contents to be covered. We teachers can explore and innovate more. This is not a demo classes. Some basic principles and ideas we are giving forward. But as you said, that is well and good. Instead of giving answers simply, if further explanation would have been there, it would be nice. So instead of doing 50 questions, 5 would be. That in coming days, we will think over it, madam.
Sir, can you put all this in the group, sir? All the questions and answers what you gave today.
I'll put in the group, madam. The complete program, the PowerPoint presentation will be put in your region group.
Thank you, sir.
Madam. All can go through. But still,
okay, sir. Thank you, sir.
Still innovative questions are expected in the afternoon session. We will discuss. And I thank all of you. My sincere thanks to all the teachers and the participants of this today's session. And more than what I learned, I learned so much from you today, and I express my gratitude to you all first, to our course director also. Thank you, Ananda. Thank you, teachers.
Thank you, sir. It was a wonderful presentation. Requesting Prajisha madam, if you want to say anything, Prajisha madam. Secondary.
Simultaneously, we are looking after our region also, sir, due to some technical issues and all that.
Okay. Then no issue. Okay.
Joining in the afternoon session, definitely, sir.
Okay, sir. Thank you, sir. Thank you very much.
Thank you, sir.
We will meet in the evening session.
Sure, sir. Sure, sir.
Thank you, sir. Thank you very much, sir.
Thank you, teachers.
Sir, please post the evening tasks in the group.
Sure, sir. Immediately.
Okay. Thank you.